And also you can observe this table, various order of the reactions, zero order, first order, second order. These are the integrated equation. And also graphical representation order, graphical method also is there. That is the graphical representation, various graphs. Graphical representation also completed. Now half-life method. What is the half-life method, sir? It is also called fractional change method. Third one is fractional change or half-life method. What is fractional change or half-life, sir? Simply the time in which the concentration of the reactant can be reduced to one half of its initial concentration of the reactant. The time in which the concentration of the reactant can be reduced to one half of its initial concentration of the reactant is called fractional change, or it is also called half-life method. It is based on the relation of the time required for completion different fraction nth order depends upon the initial concentration of the reactant. It is denoted by T half or T 50%. It is directly proportional to the a power n minus 1 and inversely proportional to the it is directly proportional to 1 minus n, or T half is inversely proportional to the a power n minus 1. That means the half-life reaction is directly proportional to the a power 1 minus n. Now if you take here T half 1 is directly proportional to the a power 1 minus n, and T half 2 is directly proportional to the a2 power 1 minus n. This is equation 1 or equation 2. Or if you take this term one also, different half-life reactions, T half 1 is inversely proportional to the a1 power n minus 1. T half 2 is directly proportional to the a2 power n minus 1. Either this one or this one, dividing equation 1 and 2, we will get here T half 1 by T half 2 is equal to a2 by a1 power n minus 1. a2 by a2 by a2 by a2 by a1 whole power n minus 1. By applying logarithm on both sides, log, this is T1 by T2, you take this one, log applying n minus 1 into log of A2 by A1. Now here log T1 half or T1 by T2 is equal to n minus 1, this one term transfer that side, log of A2 by A1 minus 1 transposing that side, 1 plus log of T1 minus T2 by log of A2 minus log of A1 is equal to the n. N means order of the reaction. N is equal to 1 plus log of T1 minus log T2 by log of A2 minus. This is the order of the reaction by using how to calculate the order of the reaction by using of. If you take this one either T half or T1 half, T1 by 2 1 or T1 by 2 2 also. a T half 1. Finally, what is the integrate nth order here? N is equal to 1 plus log of T half 1 minus log of T half 2 by log of A2 minus log of A1. This is the formula. I hope it is clear. This is information about fractional chain or half-life method, how to determine the order of the reaction. What is the half-life method or fractional chain? The time in which the concentration of the reactant can be reduced to 1/2 of its initial concentration of the reactant. And fourth one is 1/2. Differential method. 1/2 differential method. Actually, in this method, the rate of reaction observed in different reactions, different initial concentration of the reactant. Let the rate of reaction is R1 and R2. Now I am taking rate of reaction of first one, second one. Concentration of the reactant C1, C2. Initial concentration after some time. Already you know rate law or rate equation. The rate of reaction is directly proportional to the concentration of C power n. That means Nc gives rise to product. So take C1 or Nc2 gives rise to product. R2 is directly proportional to concentration of C power 2. Is nothing but R1 by K, R1 into K, concentration of C1 power n. R2 is equal to K, concentration of C2 power n. K gets cancelled. Here we will get here, this is equation 1, this is equation 2. Divide equation 1 and 2. R1 by R2 is equal to C1 by C2 whole power n. By applying a logarithm on both sides, log of R1 by R2 is equal to log of C1 by C2 power n. Log R1 minus log R2 by log C1 minus log C2 is equal to n. This is the order of reaction by using of 1/2 differential method. How to calculate the or determine the order of the reaction by using of 1/2 differential method. I hope it is clear. And finally, Ostwald isolation. And finally, Ostwald isolation method. Ostwald isolation method. Actually, what is isolation? Isolation is constant, same. Actually, in this method is used mostly in those cases to where more than one reactant is present. It is known as isolation method. If the reaction containing two or more reactant, one of the reactant acts as isolated, another one becomes constant. The last overall order is obtained by making the sum. In this method, the partial orders may also be obtained by observing the effect of concentration change of one of the reactant keeping the other reactant constant. For example, if you take here Ma, Nb, OC gives rise to product. The order of the reaction K into concentration of A power m, concentration of B power n, concentration of C power O. Here order K is equal to, in the first experiment, you can observe here, concentration of B and C are the becomes constant here. That means if the reaction having two or more reactant, one of the reactant act as isolated, remaining are the becomes 0. So that's why R1 is equal to K into concentration of A1 power M, R2 is equal to K into A2 power M only. Okay, dividing these two terms, R1 by R2 is equal to concentration of A2 by A1 by A2 power M. This is the, you can observe here the overall order. From this we can find that M is order, changing of concentration of C, value of N and O are obtained. Overall order is equal to, the overall order is equal to sum of the powers of the concentration terms. Overall order is nothing but M plus N plus O. This is the overall order. So these are the methods to calculate the order of the reaction. I hope it is clear. And last concept present in the chemical kinetics. I hope it is clear how to determine the order of reactions. There are various methods. The first one is integrate rate equation method. Second one is graphical representation. Third one is fractional change or half-life method. Fourth one is Van 't Hoff dilution method, and fifth one is Ostwald isolation methods. These are the methods to determine the order of various chemical reactions. Thank you. Okay, thank you one and all. Okay, we will meet another video.